In this video, we will be discussing about the number of atoms that are present in a given unit cell. The number of atoms, or you can say the number of atoms that belong to only one unit cell. Before we start this, it is important for us to understand the the contribution of each atom that are present at the corner of the unit cell, and the contribution of each atom that are present within the body or within the face, and so on. To get a clear picture about that, I have to draw one unit cell which shows the contribution of atom that are present at the corner here. Let's try this one first. This is one unit cell as you've seen, and in this unit cell there are 8 corner atom. Say 1 here, 2, 3, 4, 5, 6, 7, 8. Let me further try to increase the number of unit cell in this picture. Now, in this picture, if you observe carefully, you will see that there are 8 unit cells. This is one unit cell, 2, 3, 4, 5, 6, 7 there at the back, 8 here in front. And all these unit cells, if you see carefully, you will see that they are in touch with one corner atom. They are in touch with one corner constituent particle or one corner atom, that is this one. Here is the one corner atom. That unit cell which is at the back is in touch with this constituent particles. The unit cell which is in front is also in touch with this one, 2 unit cell. Now that unit cell which is at the back or this one which is in front, they are also in touch with this unit cells, altogether 4. Here the unit cell which is behind and the unit cell which is in front is also in touch with this constituent particle. So the number of unit cell which share this constituent particle is 6, and likewise 7 and 8. All of them, if you see carefully, you will see that there are 8 unit cell which shares one constituent particle, isn't it? What am I trying to tell you here is that in a unit cell, the atom which is present at the corner is shared by how many? Is shared by 8 unit cell. You got that? Okay, I'm gonna draw here another unit cell. This one, I'm gonna draw here another unit cell. This is that unit cell, a simple, or you can say a primitive unit cell. In this primitive unit cell, if you remember by definitions, you will see that the constituent particle are present only at the corner and one within the body. So this is that primitive unit cell which in a primitive unit cell, if you remember carefully, you will see that there are constituent particle which is present only at the corner. There is no other extra constituent particle at the face or no extra constituent particle within the body. So this is the primitive unit cell. In this primitive unit cell, what do you see? You will see that there are 8 corner atom, 1, 2, 3, 4, 5, 6, 7, 8. So how many unit cell are there? There is only one unit cell. And if you remember from the previous structure that I have just shown you, you will see that constituent particle that are present at the corner is shared by how many? Is shared by 8 unit cell. So according to this figure, this is also a constituent particle, this also 3, 4, 5, 6, 7, 8, and each of these constituent particle are shared by how many? Are shared by 8 unit cell. So what am I trying to tell you here is that I'm trying to calculate, or I'm trying to show you that what is the portion or what is the fraction of these constituent particle that belong exactly to only this unit cell, or what is the fraction of these constituent particle that belong exactly to only this unit cell, or in general we are going to use a formula to calculate what is the fraction of each of these constituent particle that belong exactly to only this unit cell. I hope this one is clear. All right, okay. I'm gonna draw another types of unit cell, that is a phase center unit cell. Phase center unit cell. So this is the one, phase center unit cell. If you remember by definition, phase center unit cell is a types of unit cell in which each constituent particle are present at the corner of the unit cell, and there are also extra constituent particles that are present at the center of each phases. So this is that so-called phase center unit cell. There are 8 constituent particles at the corner of the unit cell, and there are also 6 extra constituent particles at the center of each phase. So here, keeping that in mind, that each constituent particles that are present at the corner is shared by how many? Is shared by 8 unit cell. Keeping that in mind, okay? And the constituent particles that are present at the phase is shared by 2 unit cell. We are going to use a formula to find out what is the portion of the constituent particle that belong exactly to only 1 unit cell. Alright, and another type of unit cell we will be discussing, or we will calculate, is so-called body-centered unit cell. If you remember by definition, in a body-centered unit cell there are 8 atoms at the corner and 1 atom or 1 constituent particle within the body. So we are going to use a formula to find out what is the number of, or what is the fraction of the constituent particle that belong exactly to only 1 unit cell. Okay, I'm gonna start now. So the topic that we are going to discuss today is number of atom per unit cell, or you can say number of atom present in a unit cell. Number of atom in a unit cell. Please keep that in mind. If I said this is a body centered, and by just looking at the figure, it is clear to you that there are how many? There are 8 constituent particle, or you can say, okay, of course, if we assume that the constituent particles are atom, then I will be using the term atom. Anyway, from now on I will assume all these constituent particle are atoms, and I'm gonna use the term atom from now on. Okay, now in this body centered unit cell, if you, by just looking at the figure, you've seen that there are 8 atoms at the corner and 1 atom in the body. Now if I ask you what is the number of atom in a body centered unit cell, you will say 9, isn't it? No, it's not true, because if you remember from this previous figure that I have just shown you, this atom is a corner atom, this atom is a corner atom, corner, 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 and each of these corner is shared by how many? Is shared by 8 unit cell. Now only 1/8 of these belong to 1 unit cell, only 1/8 of these belong to 1 unit cell, and so on. You got this? Now we're gonna use that information to calculate what is the number of atoms that belong exactly to only 1 unit cell. So number of atoms that are present in a unit cell. What type of unit cell that we are going to discuss first? First of all, we will discuss a primitive unit cell. Primitive unit cell. Primitive unit cell. You will also call it simple cubic. Okay, primitive unit cell, or you can also call it simple cubic. In a primitive unit cell, the constituent particle or the atom are present only at the corner. The constituent particle or the atoms are present only at the corner. That is called a primitive unit cell. This is the one which I just draw. 1, 2, 3, 4, 5, 6, 7, 8. Isn't it? Alright. Now, I'm going to write here. Primitive unit cell. The atom are present where? only at the corner, are present only at the corner. Now, do you remember what is the contribution of atoms that are present at the corner? One atom that are present at the corner is shared by how many? Is shared by 8 unit cell. One atom that are present at the corner is shared by how many? 8 unit cell. Now, how many corner atom are there? There are 8 corner atom. Alright, we're gonna use that information to calculate. I'm gonna write here. Therefore, contribution of atom. Contribution of atom that are present where? At the corner. That are present at the corner. That are present at the corner equal. Remember, one atom is shared by how many? Is shared by 8 unit cell. How many corner atom are there? There are 8 corner atom. You can sell this one. So what left here is 1. What is the information that you draw, or what is the conclusion that you draw from here? The conclusion that you draw from here is that even though you see that there are 8 corner atom which is present in a primitive unit cell, but if you calculate, if you take a fraction of this one, here, that belong exactly to only this unit cell is only how much? Is only 1, alright? Or you can say the fraction of atom which belong to only one primitive unit cell is 1. Okay. Okay, the second one I'm gonna use here, I'm gonna calculate is for a body-centered cubic, a BCC, body-centered cubic. That is, if you refer in terms of figure, that is the so-called, this is the so-called body-centered cubic. What do you see? In a body-centered cubic, there are 8 atoms which is present at the corner and 1 atom which is present within the body. Keeping that in mind, that this corner atom is shared by 8 unit cell and the atom which is present within the body is shared by only 1 unit cell. I'm going to use that information to calculate, okay? So, right here, body-centered cubic contain 8 atom at the what? At the corner. And where? And 1 atom within the body. And 1 atom within the body. 8 atom at the corner and 1 atom within the body. Right? Okay. 1 atom within the body. 1 atom within the body. Contribution of atom present at the corner. What's the formula? Equal to, remember, 1 corner atom is shared by 8 unit cell. There are 8 corner atom. Now if you cancel, okay, and contribution of atom present where? Within the body. Within the body equal to, remember, 1 atom that is present in the body is shared by how much? Is shared by only 1 unit cell. 1 atom that is present in the body is shared by how much? Is shared by only 1 unit cell. And how many corner atom are there? There's how many unit cell are there? 1 atom which is present within the body is shared by only 1 unit cell, and there's only 1 atom. You got this? Therefore, number of atom present within the BCC, within the body-centered cubic, equal to contribution of atom from the corner plus contribution of atom within the body is equal to 2. Now what is the conclusion that you draw from here? Even though you see that there are 8 corner atom, 1 atom within the body, but the contribution of atom from all the corner will be equal to 1, atom within the body will be equal to 1, so the number of atoms that belong exactly to only one unit cell is how much? 2. Okay, alright, now we will move on with the next one, that is a face-centered cubic. Face-centered cubic. Remember that this is the face-centered cubic. What do you see? In this face-centered cubic, there are 8 atoms that are present within the corner and 1 atom that are present at the center of each face. You got this? Now, you have to remember, in a face-centered cubic, the atom which is present within the face is shared by 2 unit cell. I'll take this example. I hope that I will be able to clear you with this one. This is 1 unit cell here. I'm gonna increase this unit cell into 2. Right? I'll put here 1 atom at the face. Now if you remember, if you see carefully, this face is shared by this unit cell as well as this unit cell. Now if these 2 unit cell is sharing this phase, this atom which is present at the face is also sharing by 2 unit cell. So the formula that we will be using is that 1 atom that are present at the face is shared by how many? Is shared by 2 unit cell. Altogether, how many phases are there? There are 6 phases. I will multiply it by 6. If you cancel, you'll get here 3. Right? I'll use that information to find out the number of atoms that are present exactly to only one face-centered cubic. Third, face-centered cubic. Face-centered cubic contain 8 atoms at the corner and 1 atom at the center of each faces. At the center of and 1 atom at the center of each face. Alright, what is the contribution of atom that are present at the corner? Here, contribution of atom at the corner equal, remember, 1 atom that are present at the corner is shared by 8 unit cell and there are 8 corner atom. As a result, contribution of atom at the present at the corner is equal to 1. Okay, I'm gonna write here again, contribution of atom at the faces equal to, this is the formula, 1 atom that are present at the face, I've just shown you here, is shared by how many? Is shared by 2 unit cell. Now how many faces are there? There are 6 faces, isn't it? 1 atom that are present at the corner is shared by 2 unit cell and there are 6 faces. If you cancel here, remaining is 3. Now in a face-centered cubic, the contribution of atom present from the corner is equal to 1, contribution of atom present at the face is equal to 3. Therefore, number of atom present at the present in FCC equal to 1 plus 3 will be 4. Now the number of atoms that are present in a face-centered cubic is equal to 4. Thank you.